This is our headquarters, and we have the production of the 3D printers. And so this is Shambhala Park, where we made our vision real.
So this is where you print the houses?
Yeah. And here the tiny Gaia, but we love here so much because it was a proof of concept for us. We started around 9 years ago at WASP with the aim to print house, but eco house using local material and basically soils from the place. This is our big aim to reach. This tiny house for us is the symbol that the project could be real, can happen, can work properly. So we take directly the earth by the place here, and so every time you have a house, 3D printed one, you have also a small lake.
So you have a small lake because you took the earth to
directly.
the house.
Yeah.
So whenever you build an earth house, you're always going to have a lake.
Yeah.
Your quarry.
Yeah, it's kind of circular because the rooftop collects the water, and so when it rains, the water is collected here and returned directly to the small lake you have, and can also use to cultivation. And so we have here fish also, so like a sort of ecosystem. You not only take from the earth but also give something. And so we think 3D printing and technology can really help us to go this direction. There's a rooftop because for clay house traditionally you have to cover and protect the wall because there's any treatment on the surfaces. So it's regular clay.
It's untreated.
Untreated, yeah. And also you need big boots.
The boots.
Boots, sorry.
Hat and boots, as they say, right?
Yeah. Because the same, we have to protect from the water. This is the way they traditionally create earth house. We just print it instead of use hands. Ta-da! Yeah, this is Gaia, the first proof of concept that.
So it's made of what? What is we seeing in the walls here?
This is a clay. It's a raw earth we took directly by the place because of the lake. We go to have like a traditional mix design for a earth house, but we create for being 3D printed. So we took directly the earth by the place. We put some fibers like straw or husk of rice, because we have a lot in Italy. It will change place by place, no? But the mix will be always the same. Clay, sand, fiber, like your natural fiber, straw, hemp, whatever you have around you, and insulation inside the wall. And also we take the layers natural for show people which technology made the house, but you can also cover and know nothing about. And it's a really big wall, and so for insulation and for temperature inside. So we are trying to put together the way to construct, like a contemporary construction, but using natural material.
And what about the structure? Why is it small and round?
It's round because the printer we have was only one, and this was the maximum size we can reach, but we scale up fast. Okay, we have here, this machine was the biggest 3D printer in around 6 years ago. It's 12 meters tall. It was like a dream for a maker like us and for our group of research and followers too. Tekla was the dome. It's kind of symbol for 3D printing. It's remain a topic for 3D printing because you want to go on the place, print directly without any rooftop and without important structure. Dome is not an easy thing with earth, so maybe with concrete is easier for sure.
Because of the strength.
Yeah, because of the collapsing or yeah, it's not easy. So we will need for sure time to investigate more and more on dome, but Tekla is a really good beginning for sure.
Yeah.
This is our headquarters where we make our evolution in terms of technology. So we are on 3D printing in general, so we sell machines like this one. One of the most interesting one is this one for pellet. This way we can print directly the grain of plastic. The grain instead of the filament, we use directly the pellet. This is pellet. Yeah, that way we can open a new world of material to use and to print.
And that's plastic?
Yeah, it's plastic and could be also recycled plastic. Also rubber, like this one. It's 3D printed too. This is nylon carbon, really strong and super smooth. Also this is made by recycled plastic.
So that would come from, you could just recycle, for example...
Yeah, this is this material. For sure you cannot put directly all recycled plastic, you have to add something new because the power of the plastic is not the same, but you can use a lot to recycle inside. So the surface is not perfect, but this is not the focus, no? And we have here ceramic.
So all this was printed?
Yeah, this is printed, this is porcelain. Why? Because we start to investigate natural material in order to scale up the process till the big machine you saw in the garden, because no one prints clay or earth. When we began this company, we started to investigate clay.
Difficult to print with clay. Is it messy?
In the beginning, yes. But now there's more big application and people start to know about, but it was a kind of new stuff. Mm-hmm. But we start to investigate clay.
Wow, it's very precise and detailed, right?
Yeah. And we play scale it up. The printers still have like big object like this one.
It's a mix of art and industry here.
Yeah. Yeah, we are also close to Faenza, where there's a lot of ceramic, tradition and pottery. So I attended Ceramic University.
As probably since Roman times you have a very strong tradition, and now you are taking on a different step on...
Yeah. This is a new one we made with Honda, the motorcycle company. This is industrial clay. You can print and reprint for infinite time the material and smooth the surfaces. It's super cool. And then you go with a reverse engineering and take the surfaces on the computer and then work again on the design and print again. It's a kind of assistance for your design object to recreate the shapes of the motorcycle or a piece of car. And here, the section about architecture. We made Gaia, Tekla, that prove us the project could work properly. This is the crane mast. So we decide how many machines we have to use accordingly to the project we have to print. Yeah, you have to put obviously the pump here, and this is the robot that we use for printing Gaia, Tekla, all the same.
So printing with earth?
Yeah. Right now it's kind of a ready-to-use machine, but what we have to do is to investigate a lot on material. Because we work right now with the rice house. They provide us this material. It's a really stable one, but it's premixed. So our big objective is to go locally and use local soils. But we have to investigate more because it can change place by place. We usually ask locally to send us some earth to try to print here before going directly.
So this would just come straight from the...
This is from our garden, yeah? but also potential clients send us earth to try to print, or we investigate how the stringiness, how it works. Huh?
Yeah.
So we usually print a small object like this with the 3D printers for clay. Additional clay, we scale up till this pre-mixed material or new material too. For example, this is geopolymers. No, because it's really interesting. Nobody investigates too much on this material.
What are geopolymers? What?
Let me ask to Massimo. Babbo! So it's an alkaline reaction, traditional use also in the past.
Ciao.
Cos'è questo?
Queste sono ricerche su vari materiali. Stiamo cercando dei geopolimeri, è come si chiama, noi lo chiamiamo cemento verde. Poi il cemento si ottiene con una cottura a 1500 gradi,
Sì.
Quindi hai una grande emissione di CO2 proprio per il processo. Invece il geopolimero non è altro che trovare due componenti che si miscelano assieme, che creano una reazione naturale, è un po' il processo della pietra, solo che si ottiene miscelando terre particolari che vanno cercate. Da qui credo che avremo delle belle possibilità, innanzitutto perché ti permette di fare degli oggetti che hanno una caratteristica simile all'oggetto cotto. Questo per dire è un'argilla che dopo viene cotta e non è un geopolimero, questa è cotta, a bassa temperatura ma è cotta. Questa invece è fredda, è reazione fredda, però questa è a tutti gli effetti anche più robusta di questa. E quindi è tutta una ricerca, è il cemento verde. Per esempio questo è un geopolimero per me molto interessante perché il problema della stampa 3D è riuscire a ottenere una polimerizzazione o un cambio di stato del materiale in dei tempi adatti alla stampa. È chiaro che se ti cambia di stato dentro l'estrusore devi buttare via l'estrusore, no? Questa è una pompa che abbiamo fatta noi, che ha due sistemi, uno che spinge fuori il materiale e un altro che contemporaneamente lo miscela, con due motori. L'ideale per la questione come i geopolimeri, perché i geopolimeri se li lasci fermi cambiano di stato, finché li muovi non cambiano di stato. Quindi abbiamo sviluppato un sistema apposta per quei materiali.
You're pioneering.
No, perché nascono dal nostro bisogno. Cioè, noi prima di fare questa usavamo una pompa commerciale, però dovevamo stare sempre con le mani a spingere. 8 ore. C'era lui, Def, com'era? Però questa qui è sotto brevetto, lo diciamo? Allora, questo ad esempio, vedi, un estrusore molto difficile da costruire, perché tu puoi buttare dentro il materiale e questa macchina lo butta fuori. Questo invece è il primo sistema che veramente mi risulta al mondo continuo per la terra.
How many years have you been experimenting?
9 years. Let me show you. This is our beginning. We buy with the colleague of my university these machines, but we are designers and we don't have any skills about electronics. So I thought, okay, we have a couple of friends of mine that want to make these printers run. So we start thinking that we can do something bigger, and we start with this.
That's the first wasp printer.
Yeah, Power Wasp. It was a machine for makers, because you can change the tools and you can use a syringe or you can print. There are also milling tools. We experiment a lot with this, and all the best makers have one. A lot of hacking. And then we start to thinking about Delta, because we thought it was the best way to scale up for F houses. And this is our first ceramic 3D printers, where we put here the clay. There's a motor here that pushes down a piston or something similar, and we print without any retraction. Then we moved to the screw inside the extruder that made the possibility to stop the printing and move differently, so a more sophisticated way to print, and we create a line for clay directly.
This is not all, but some of the code that we made for Tecno. This is the entire model of one of the two domes that we print. Okay, you can see the internal part of the wall, so you can see the structural part, that is the blue one. The furniture part, this is the white one, and externally the orange and red one are the part that we use to create a natural ventilation in the outer part of the house.
Our main work is about the infill of the wall. I think it's interesting because it's kind of really specific from our technology.
Let's say the middle part of the wall is the thicker part, then skipping into the inside for this kind of niches for structure, and the cavities of course for insulation, and then outside the pattern has to be the hardest part of the wall for weather condition and so on. And you can also, for the future, thinking about different materials for different paths. It's about like tailoring the wall, and every time we optimize a pattern and the texture for the inside wall, because we are used to work like this, like really closer the machine to the code, to the codification of our work.
What we can see here and here, for example, and also here for the concept store we made for Dior. I met Luca Alberos from Dior, and he was really fascinated by what we can do with the natural material. The most particular things we have on this pop-up store for Dior is the surfaces, because this is the traditional, very famous canage from the Maison, and we put it on the surface. So we do like a tech tailor, no? Because layer by layer we create these surfaces. We use clay, raw earth, a bit of sand. It was a mixed natural materials. This is a section of the Dior wall, because we made a section here to try the surfaces. This canage, like a tailor made on the printing. We tried this material here, and we print in Dubai. Something really, really similar. And I think no one made something similar before. We have here something, it's like a staircase. We made with this university, AIAC. They are really on earth houses, and we try to create this. This is a staircase directly in a 3D printed wall. So this is like a frame, because they have a really big project, like a villa, where the staircase is directly put into. So this is really experimental, but yeah.
It looks very, every shape, and it looks almost like it's biomorphic. It's like animals from the sea, plants.
Yeah, we can play this way with 3D printers, because bricks, bricks we already have, it's squared. With 3D printer we can push the design.
Questo è un pezzo della Casa delle Api.
Oh, okay.
Bee house.
Like wasp.
Yeah, we work for our parents.
Apicultura del futuro?
Sì, stampata 3D. Isolamento termico per l'ape.
Sì. Il biomorfismo e animale comprendrà.
Sì, abbiamo studiato la psicologia dell'ape per fargli una casa che gli piace. No?
Sì.
Yeah, it's an idea of Massimo to creating a sort of controlled environment around the house, just to allow the cultivation of vegetable and algae and other organisms.
and why not a way to create vegetables instead of eating animals.
So that's a 3D printed.
Yeah, like hydroponic.
Planter?
Yeah, hydroponic culture. Yeah, we are investigating on it. We have had 4. It works properly.